Okay, guys, we might get started. There's going to be a lot of stuff to get through, given that there's a mock audit at the end of the session. So just be aware that Kunti has already mentioned to me that it's highly likely we're going to run 5 or 10 minutes overtime because of the mock audit, for those that want to participate in the audit at the end of the session.
Welcome to the Technologies 4 session, Quality Assurance and Accreditation. Our first lecture is from Dr. Colin Baker. It's the name of the lecture is National Standards and Accreditation.
Just like to thank the convening committee for allowing me the opportunity to present this afternoon, talking about quality assurance and accreditation. It's a very stimulating subject. It's a very detailed process that goes on in all health services. This is really just a simplification of what it really means to imaging. The overview of the presentation today is background and aims, methods, developments of the 10 standards, results and conclusions. With a bit of background, the National and Quality Health Service Standards that were developed around about 2011 and they were made, generated by the Australian Commission of Safety and Quality in Healthcare. These particular standards were put together and reviewed. There was 5 standards initially generated in 2011, another 5 in 2012. In 2013, they were made mandatory for all Australian health services to put in place. There are 3 main things with regards to the standards: obviously the definition of what they mean, the intent, and the criteria. So the aims of the standards, as we can see here, organisations are accountable and continually improving the quality of their services, safeguarding high standards of care by creating an environment in which excellence in clinical care will flourish. And this has been in place since, as you can see, since the late 90s, and it's had several names over the last 20 years. Part of the standards is to put in place structures and systems within organisations, as well as the processes that have to be followed, not only from an organisational view, but all the way down to the individual staff members. Part of that process is putting in place committees and groups and having feedback through that process. So each of the 10 standards, they drive the implementation and maintenance of the safety and quality systems within the organisations. But there are 2 main standards that are very important, and they're throughout all of the other standards, and that's the governance of the processes, so governance for safety and quality, and partnership with consumers. And you can see those streams right through the 10 particular standards. There's certainly can be core, and they can have the critical or safe or quality and must be met within that process. But they're also developmental, so your aspirational targets, and strive to meet these within those processes and actions. So how are they introduced into health services, and how do they relate to us? So very briefly, I'll go through the 10 standards and just give you a very brief overview of what they mean to the organisation. More importantly, what we do within imaging and how they actually relate to ourselves. And with regards to that, they can also be a general view of the particular standard. They can be specific, depending on what we're doing within our particular area, and they can also be workflow related. These are the 10 standards. I'm assuming that people have seen them, certainly from the Australian background. But currently the 10 standards, they've been in place for 5 years. Austin Health, for example, have gone through the accreditation process of these standards twice in the last 5 years, and we're about to go through the 3rd assessment in October this year. So standard 1, governance for safety and quality in healthcare. So what is governance? It's the overarching role and responsibility to make sure that the standards are put in place appropriately and they're being monitored for the practice that's in place. It's very important from the point of view of the organisation that the board of the health service is responsible for this process to be put in place appropriately. And certainly through that process, there are committees and groups frameworks and processes put in place, and then at the end of that process there's an assessment, so that it's a closing the loop and then re-initiating new processes that may be not being performed appropriately. One of the other things as part of this process, again, as it is with every process, there needs to be appropriate skills within the organisation to have these rolled out, but also from our point of view, or imaging's point of view, there needs to be some expertise within the local departments. So what does Standard 1 mean to us? Obviously we have policies and procedures, and excuse me, and also mandatory training as part of that process. And they're just a list of a few of those that we're probably well aware of. We have, certainly at the Austin, things called risk mans, so we have a process where we can actually document errors that are occurring or near misses. And again, appropriate patient documentation. So Standard 2, as we said before, is the other one that's very important, and that's partnering with consumers. And a health service that is responsive to patient care and consumer input needs, and what the organisation is doing through these standards is making that the consumer is part of their treatment process. They're empowering patients and have some control of what type of treatments that they're actually receiving. So what do we do within imaging for this process? So most organisations, and certainly within imaging, we have patient feedback processes, or MySay at the Austin, for example. We have documentation that patients can actually feedback through the organisation at a local level or at an organisational level for feedback as how they perceive their particular care. We also have, as part of the process, certainly in organisations, there are consumers on many of the committees around the organisation, and also through that process we have consumers on local committees. As part of that process that's built in, we also have both consumers as well as staff that are trained to review documentation that's given to consumers, certainly patient information on examinations that they're having pre and post care, so that the information is understood and is at a level where the patient can understand it. Standard 3 is preventing and controlling healthcare associated infections. As far as the organisation, preventable healthcare associated infections, and it's all evidence-based, so there are lots of processes put in place as far as cleaning the organisation to reduce the amount of potential risks, both for staff and also for the patient's care. Austin, for example, has many products that they can use as they come into the organisation, whether it's a solution or it's a cream, to actually reduce the infection from touching equipment and patients as they come in. So again, as what we said, there was certain processes that we have to put in place, and we have preparation of the environment. So that's cleaning everything. The environment has to be cleaned. The 5 moments of hand hygiene is probably prevalent across most organisations now. Clean and share equipment, and also what's coming in very importantly as far as the immunisation of staff, to reduce the risk of staff gaining infections from patients themselves and passing things on to patients. Medication safety. It's really simply to ensure the competent clinicians prescribe, dispense and administer the appropriate drug that's been required. Documentation of this has to be done adequately, because one person might be having to do one set of medications at one time and somebody different at another time. Within imaging, there are different things. There's certainly radiopharmaceuticals, contrast medium given to patients. So certainly we have to have the protocols set up clearly to know what the patient's receiving, correct doses, the appropriate QC on what's been given, and also know risk factors as far as renal function and consent. As part of the process of checking patients' information, checking allergies to make sure the patient can receive what's being protocoled. As part of that process, having additional processes in place in case something does go wrong, we can actually document and manage the process at a later time so the patient doesn't receive the same dose of contrast, for example, at a later date. Standard 5 is patient ID and procedure matching. One of the most important things within the organisation is correctly identifying all patients whenever care is provided and correctly matching those patients to the intended treatment. Certainly from radiology's point of view, and we do this vigorously and people get possibly a little tired of it and so do patients. However, it's very important that we do the 3-point ID checks. Certainly slightly different for inpatients as opposed to outpatients. Clinical handover. So an extension of the last standard. Clinical handover is an extension of that so that we're actually including a little bit more information when we hand the patient over from one department to another department, or from wards to theatres, or theatres to back to the wards. So handover is essential and involved the delivery of the patient care across the organisation. For example, ISBAR is an example of the information, certainly that has to be handed over from one person to another person so that the continuity of care of that patient is continued. Within certainly imaging, there are separate documents that we have, certainly handover documents that have to be approved through the organisation to be utilised and have the information that's required, such as ISBAR. It's certainly very important when patients are coming down, certainly from radiology's point of view, when they're having an interventional case, to make sure that the appropriate clinical information is handed over. So the patient can then be treated appropriately, additional documentation is made, and again that patient's information and clinical assessment is handed back to the staff in the ward. Standard 7, blood and blood products. Certainly impacts the wards, pathology, imaging. People tend not to have a look at this very closely, but the important thing with this is the right patient is getting the right blood for the right reason. And we do in fact do this across imaging. Certainly from the point of view, there are some cases where patients' bloods are taken. There has to be appropriate labelling of that process so that the patient's receiving the process back. Some of the interventional cases that we certainly do in radiology, patients in those cases do have to receive blood, and we have to make sure that we're following the right appropriate documentation within the organisation, making sure the right patient is receiving the right blood, but also to recognise if something's not right and to stop the process and document it appropriately. So standard 8 is preventing and managing pressure injuries. From the point of view of a lot of the patients within imaging, they tend to be a little bit transient. There are some cases that take a fair time within imaging. They can take up to an hour and a half, depending on some interventional cases. They can be there for quite a while. So again, the handovers are very important to receive the appropriate clinical information and any information about pressure injuries or major risk from the patient's point of view, and being able to maintain that integrity of that information. We certainly don't want to make the process any worse while they're sitting in imaging. Some of the things that we can think about, certainly from the imaging point of view, arm boards, sponges, sliding sheets. One of the most important things is, again, replacing pressure relieving devices back with the patient. They may not necessarily be able to be used while the patient's having their particular procedure, but we have to make sure that that all goes back appropriately as we receive them. Standard 9 is recognising responsible to the clinical deterioration in acute healthcare. Again, one of the handovers, again, the information from the clinical perspective to recognise that if the patient is deteriorating promptly, certainly notify medical staff, nursing staff. Also, from the process of some of the examinations, making sure that we're taking the appropriate observations of that patient and monitoring them as they would be in the ward or in ED or where the patient may have come from. Very important to escalate that process. So again, understanding what the organisation requires as far as the criteria set for a patient's deterioration, and if their nurses or the clinical outlook of that patient meets some of those criteria, is then to escalate it. And we may have to, in some cases, call MET calls or code blues, depending on which level of criteria they've actually met. Again, part of the process, handing back is ISBAR. As much information as possible has to go back with the patient. Standard 10, preventing falls, harms from falls. Again, part of the process is that most patients, certainly within the Austin, within the first 72 hours, have an assessment of falls risks. Part of that process is then put into the patient's history. It's part of the handover sheet. It's part of the ISBAR that comes down with the patient. And from our perspective is to be aware of the handover sheets, and everybody's aware of that, whether it be the nurse, the technologist, the technician. One of the things, in addition to that, is that for certainly patients, our patients walking into the organisation, is the fact that we assess them visually at all times. So these patients may come in with a walking frame, they may come with a wheelchair, a trolley. So at all times are we making the assessment of that patient at all times. Wrong way. Okay. Now, as far as the whole process is concerned, over the last 5 years, the Commission has done a review of the 10 standards, and they've come back as from 2019 is version 2, and there are only 8 standards to be followed. 7 of them are really virtually the same. It's really only standard 5 that incorporates certainly standard 5, 8 and 10 of the previous ones. So they've accumulated those 3 together, which puts together the comprehensive treatment of those patients. So these are the ones that will be initiated in 2019. So what do we have to do? So part of this process is very integral with what we do within the organisation, but also within the department. Each departments have quality business plans, and if we don't have plans in place to put some of these processes in, part of the quality business plan is to initiate those plans to be able to put them in place. It includes projects and activities addressed by the national standards so that everybody's following the same process that's being led by the organisation. As part of the process, certainly within most major hospitals, there's walkarounds. They have a look to see what processes are being carried out, what documentation you have in place. And what's very important as part of that process, and it tends to be the further down the tree you go, the slower it is to pick up, and that's the audit process, doing audits of how you do things. So conclusion. Along with the rigorous clinical governance expected by hospital accreditation processes, there needs to be frameworks of the standardisation for safe practices across all organisations. They have to be instrumental in developing safety and quality healthcare. And medicine is a rapidly evolving entity, one that requires measurement, such as the standards, to support safe, high-quality healthcare, at the same time provide the required clinical governance to monitor its effectiveness. One of the examples is that this is a structure that's put in place as a quick reference for people to see what the standards mean, with a few items that's sitting underneath it. And again, it's a circular process, so it has feedback built into that to change the process if it's not meeting the standards required. Thank you.
We are going to present Dr. Baker with this gift from the Executive Committee from the World Federation.
So I think we'll leave questions to the end as part of the mock audit, I think is most probably the best thing to do. So the next speaker is my co-chair, Professor Enrique Estrada Lobato. He will be talking to you today on quality management audit in nuclear medicine, the IAEA approach.
Thank you very much. And thank you very much to the Scientific Committee for the invitation to participate in this session. This is something very important for the International Atomic Energy Agency because nuclear medicine is a specialty with a very rapid evolving during the last years. And of course, quality is something that has been very important because we have to be adapting to the new times. 20 years ago in nuclear medicine, we were talking about quality control. in several of our procedures, but not about quality assurance as a whole. And for that, it's also important not only to teach what is the approach to quality assurance, but also to be able to audit the practices in nuclear medicine. Because we have to be in line with the current practice in all means in life, like the good manufacturing production of radiopharmaceuticals, the good practice in the techniques in acquiring processing studies. So it involves really a lot of procedures in the practice of nuclear medicine. So a quality management system is a means by which nuclear medicine facilities can show their level of patient care they provide, customer orientation by following a process of self and external evaluation, adherence to national or international standards, and commitment to quality of care. I'm not going to go very deep into the program because Dr. Somanesan is going to talk a little bit later about some specific topics of the program. I'm going to focus on the results of the program. But it's important to know why we should embark in a quality management program. In many countries, it's a requirement by law for accreditation with healthcare providers. In the European Union, it's a directive that it's put in place in several years. So it has to be fulfilled for all the centers practicing nuclear medicine. So and it's important for low middle income countries because the practice of nuclear medicine is really diverse in different levels of implementation. It's due possibly to the lack of financial or human resources, limited training, lack of educational opportunities, limited professional networking, the overall need to raise the standards of practice and improve performance due to competition with other modalities. So this Quantum project was born in 2006 to identify a tool to help nuclear medicine practitioners to self-assess their practices, receive an external team of auditors supported by the IAEA, of course, receive recommendations and implement remedial actions. And the output of this is this wonderful program that is called Quantum, that has been very successful around the world, not only in developing countries or low middle income countries, but also some of the activities that we perform for the audits have been taken by some developed countries to put in place as a national system in different countries, like it is in Belgium, which is, they have Quantum B. It's totally based on Quantum in our program, and it's something that is mandatory for all the nuclear medicine facilities in the country. Well, this is a very comprehensive audit. As I told you, the specific topics of the programs are going to be delivered by Dr. Somanesan, but comprises all the multidisciplinary specialties involved in nuclear medicine. You can find all the information about the program in our Human Health Campus. You go in the nuclear medicine section. You see here in the top part of the site, nuclear medicine section, and here you're going to find quality of practice. Here we have Quantum 2.0 is the second version because we started, of course, with the first version, and we had to make improvements after a few years of practice because we identify new ways to evaluate or better way to evaluate some of the issues that are reviewed with the audit. And in this, when you go to the Quantum 2 and the Excel tool, you are going to find the list of checklists that it has to be the means of verification for the audit, as well as the manual of the Quantum 2 with all the information and all the references, so you can see that it's not something that is imposed, it's something that it has the information available to explain every step of the audit. This is the the Quantum tool and Excel tool. Here you are going to find a software to train the trainers. You are going to find all the information about the program, the quality, the checklist, and of course, the frequently asked questions about the program. This is all the information that you can find about the Quantum, the manual with the references, and of course the checklist where you can see the way that is going to be evaluated, all the aspects of the nuclear medicine specialty, and if you, for example, go to this part and click here in the reference, you're going to be directed to the specific chapter of the manual where you can find the information about what we are looking for in each one of the items of the checklist. When you go to the checklist, you are going to find the second column something that is called conformance level, and then you are going to find a score there. It's going from 0 to 4, depending on if you are complying or not with that specific item. And it's going to be, if you comply, it's going to be green, or if you don't comply, it's going to be red. So it's going to mark a spotlight in the things that you have to study furthermore. Well, as I told you, this is the way you are going to be rating all the topics of the checklist, green or red, depending on the conformance level. And then you're going to get a total score for that. And of course, a polar map, kind of a polar map, with all the checklists you see here. Number 1, strategies, administration and management, human resources, radiation regulation, etc. All the means of verification of the checklist. But well, about the results of 11 years of Quantum, well, almost 12 years of Quantum, those are the countries that we have performed, sometimes one or sometimes more than one audits. In some centers, we have been able to perform a follow-up audit in 21 centers. In the rest of the centers, we try to perform a self-assessment follow-up review, and we compare the results. In that way, and all the results were published in the Seminars of Nuclear Medicine in 3 parts. The last part was published last month, so you can find the information there also. And with these radar plots in 25 institutions, you can see the pre and post results of the audit. This is the radar plot of the first audit and the follow-up audit, and you can see the changes, the improvement in the different checklists. Those are 17 checklists, and you can see how they have been improving after the first audit. This is the global number of positive and negative changes of the status of conformance for requirements from checklist 1 to 9, 12, and 14 and 17. The negative changes compared with the positive changes. This is the changes of conformance status for specific activity fields as reflected by the checklist. You can see here, checklist number 1, 2, 3, etc. And the negative changes compared with the positive changes after the follow-up audit. This is the magnitude of the level of conformance changes between the first and the follow-up audit by institution, reflected by the sum of ranks. Again, you can see here the number of institutions and comparing the negative or the positive ranks and the improvement that they had after the follow-up audit. This is the changes of conformance status and conformance levels in clinical checklists. And again, you can see the difference between the negative and positive changes in all the lists regarding imaging and non-imaging and therapy procedures. So you see here in the bottom part, the imaging, compare the negative with the positive changes, non-imaging and therapy. So the results have been really very positive. So why should we embark in an external audit? We normally have a negative perception about the audits. We think that it's going to be a very high cost, especially when we are talking about the time that the staff is going to take to evaluate all the fields in nuclear medicine practice. And it is really time consuming to have these quality assurance programs in place, because you have to review all the internal processes and you have to create the standard operating procedures for each one of the procedures that you are performing in the nuclear medicine department. And that means human resources management, administration, the clinical part, radiopharmacy, medical physics. Each one of the procedures has to have an SOP for that. So it's really a lot of paperwork that it has to be done, and it has to involve all the staff, or at least one person from each one of the sections of the nuclear medicine department. They have to be involved in the creation of the SOPs. So it's really a lot of time that the staff has to devote at the very beginning of the program, and after that to review the SOPs every year, every 6 months, depending on the procedure and depending on the standards of the nuclear medicine department. Of course, another negative perception is the lack of funds to address possible critical issues, especially when it comes to changes in the physical infrastructure of the nuclear medicine department. And it's a potential threat to the activities, of course, because you are going to take a lot of time to perform the program, and of course to implement the changes, but particularly in the mindset of the personnel. You have to change the practice from the inside. That's the worst part, maybe. And the positive side of an audit is you are going to have a different perspective of the daily routines, because you are going to be evaluated by peers. It's not like an external management personnel from other business company like it is for most accreditation programs. Sometimes you are going to be reviewed by a manager, business manager, or an accountant or an engineer. With this program, with the quantum, we are going to be evaluated by peers. So one radiopharmacist is going to evaluate the radiopharmacy, nuclear medicine physician is going to evaluate the clinical part, etc. So it's a peer review audit. Another positive side is the assess compliance at any level of the nuclear medicine center to international standards, alignment of working practices to international standards, and of course, accountability. We have another program for auditing. This is in the clinical part, and it's called Clinical Audit on Myocardial Perfusion Imaging. And this is assessing outcome of training in nuclear cardiology. And we have a second one that is ongoing, which is a clinical audit on the reporting of PET-CT studies. Related to the nuclear cardiology program, it was performed in 20 participant centers and in different regions. You can see here the regions and the total number of professionals that were evaluated. And we were mainly looking into the reporting of the studies, the nuclear cardiology studies. And the rationale and objectives of this project was assessing the outcome of the IAEA activities in nuclear cardiology and try to reshape those activities in case it was needed. And of course, the introduction of the concept of quality in reporting. And for that, we were supporting the nuclear medicine, nuclear cardiology laboratories with experts to validate their performance and quality of work, and of course, improve when it was necessary. And this is the workflow of this program of auditing in nuclear cardiology. The participating centers are enrolled. Then we have a central lab who creates the case study. and uploads to a SharePoint. The participating center was informed of the new case study by a coordinator. The participating center downloads the case study from the SharePoint, and then the study is analyzed and they create a report. They submit the report to the coordinator for a review. The reports are reviewed by a study coordinator, and then this coordinator uploads the report to Central Lab and to the SharePoint. The Central Lab analyzes all the report submissions, and then the data is released by the Central Lab. The reporting form, this is the way it was designed, the reporting form for the different areas of the study. And this is the form that we were using to collect all the information from the different centers. And then we had the initial results. They were evaluated as almost perfect, strong, moderate, weak, minimal, or none regarding the agreement level. You can see here in the different settings like function, image quality, patient high risk, perfusion. And this is in this table we can see the differences between the groups, and these differences were not statistically significant. Of course, we found out that there is a need for standardization, recognize artifacts that could be mechanical or electronical regarding the energy window, the detector center of rotation and alignment, the fluid field non-uniformity. It could be biological regarding myocardial hypertrophy, left bundle branch block, cardiac position with thorax. It could be related to the patient, like, for example, attenuation of soft tissue. It could be either breast or the diaphragm, superimposed abdominal visceral activity or motion artifacts, or it could be artifacts related to processing, like, for example, the selection of cardiac axis or the selection of the apex and base for the polar maps. And as a conclusion of these two programs, we can say that the Quantum program is the first example of a global approach to the implementation of quality management into the daily practice of nuclear medicine, with extensive coverage of clinical aspects and related components of medical physics and radiopharmacy. To the best of our knowledge, there are no data published on such an experimental approach, and in many cases, the outcomes of quality management systems implementation are assumed or expected, but not directly observed and measured. So this is the great value of the quantum audits, that we have been very much in touch with the counterparts, so we can evaluate the follow-up audits and compare the results with the first audits. And it has been really impacting in the practice of the nuclear medicine. And regarding the MPI clinical audit, we can say that it's technically difficult to run, but the results were also very good with the need to strengthen the basics for reporting the studies in myocardial perfusion imaging. And we are running the third program in reporting PET-CT studies. The results are going to be shown in few months. So I think this is it. Thank you very much. Muchas gracias.
So on behalf of the World Federation Executive, I'd like to present Professor Lobato with a small gift for his presentation and contribution to the whole meeting. I just don't know whether those in the room know, but Enrique was actually the president of the previous World Federation meeting that was run in Cancun 4 years ago. So he's had a lot of active involvement in the World Federation, and we appreciate his time and contribution to this session. like a celebrity. Okay, so on that note, we'll invite our next speaker to the stage. Many of you may know Kunti Pathmaraj. I don't think I said her last name correctly. I apologise in advance.
You just managed that, Liz.
I was close enough for layman's work. She's going to present to us today on quality assurance in nuclear medicine and PET from the perspective of radionuclide therapy.
Thank you, Liz. I'd just like to quickly acknowledge Enrique, Diana, who's here, and all the efforts of IAEA in quantum quadril. We mustn't forget the radiology counterpart, as well as Quadro, I think, for radiation oncology. Quadro. They're making a significant, enormous impact in developing nations to bring practices of nuclear medicine and molecular imaging up to scratch. Very much appreciated, I think. Okay, so you've heard a few talks now on this, and my talk actually is going to focus more on a departmental level in our department, what is quality and how do we manage quality assurance and how do we understand that. All right. So I've presented on this topic in a couple of forums. It's quite a hard topic to talk to, but I'm going to try my best to be coherent and try to deliver this in a comprehensive manner. So I thought we'll first define what quality is, and rather than, I resisted the temptation of Googling it. So I looked it up in the dictionary, and it's defined as it's the degree of excellence of a thing. So then we go about how does one achieve excellence. To answer this question, I thought it's best that we actually refer to the Deming cycle. Until the early 1950s, management of quality was generally restricted to quality control, mainly the inspection for defects in products. And even now, I think to an extent, there is some confusion between quality control and quality assurance when people tend to interchange the two terms. Anyway, from the 1950s onwards, it was actually the Japanese that began to adopt various methodologies that focused on process quality rather than just product quality. And the first and most influential of these came from Deming in 1982. He advocated a process of continual quality improvement to refine processing systems. This process was based on the PDCA cycle: plan, do, check, act. His largest impact was, in fact, in the automotive industry, but his approach has been adopted in many healthcare systems. So if you then deconstruct this Deming cycle, we check, identify the problem, assess the cause, we act, implement action to prevent problems, monitor the effects of the action, document these activities. Once the gaps are identified, then you plan on how to address these gaps. And then you implement the planned action items. Then it's cyclic, then we repeat it in a regular fashion. So this is the principle that we can follow. And now we then extend quality to quality assurance. What should we do to assure the excellence in our service that is created and then maintained? The purpose of quality assurance programs is to continually evaluate the quality of all components in nuclear medicine departments with a view for quality improvement. And what they do is they will ensure, or try to ensure, that examinations are justified, ALARA principles are adhered to, written protocols are followed for procedures, self-evaluation is conducted regularly, and continuing education is encouraged. So now we take it to the next step. Quality assurance can establish the framework for quality management, which Enrique briefly alluded to in his talk. Quality management principles have a customer focus and revolve around patient-centered care. It encourages leadership. Leaders establish unity of purpose and direction of the organization. Let's now look into different approaches for quality management from 4 different perspectives that are linked to sometimes, though, diverging interests. And this is the slight problem that we face, the diverging interests. at these 4 levels. There's the system levels, the organisation level, individual professional levels, which is what we are most interested in, as well as the user levels. At the system levels, there are laws and regulations that have been created with the aim of improving the quality of the service and safeguarding fair services and equity among service providers. The national standards and guidelines that you've heard about from Colin have been devised to support local authorities to develop a service provision that meets the needs of the population. At the system level, inspection is the most common way of assuring minimum quality standards. There's usually a national body to inspect each organisation or an institution. Accreditation is voluntary, but sometimes it is compulsory method of quality assurance. It's usually carried out by an independent third party. Larger organisations have started to use quality management for strategic reasons, due to the fact that there's increased number of competing institutions, and there is, of course, importantly, compliance with external requests for transparency. We, the professionals at the professional level, are at the front line in managing quality of service for service users. We must be constantly aware of any change in service user status and devise interventions to improve outcomes. Outcomes, of course, depend on the right skill mix of professionals working together, and in a modality such as ours, it's usually a very multidisciplinary approach. At the professional level is also staff development pathways. Continued professional education and skills is essential, as well as the fact that all professionals should be accredited and registered at a system level and qualified to practice the profession. The quality management system has to be implemented, and one way to implement it is via what's called a process map. And this is something that is taken out of IAEA Quantum 1, I think, and then it was expanded in Quantum 2. And I find this is a very useful tool to understand how a department works. So it basically stratifies a department in the following manner. Primary processes, which is the central part that you see, which is basically the core clinical operating services of the department, and that is the primary process. The management process, which is sitting above, and what that serves to do is guide the formation and maintenance of the primary processes that we just referred to. And beneath it lies the support processes, of which quality features there as well, and it serves to support the primary processes. In order to ensure that the process map works well, we need to have accurate documentation. So quality and quality assurance revolves a lot around documentation. Documentation can take the shape of many forms. The quality manual is one, quality and risk manual in some places. Documented procedures can also be SOPs, protocols and work instructions. Examination protocols must be up to date, revised when necessary. Protocol changes must be communicated to all staff, and very importantly, documents have to be version controlled and obsolete versions must be archived and put out of circulation. If we now look at how we can apply quality assurance in our day-to-day activities, in the next 4 or 5 slides, we'll just whip through this quickly. QA program in nuclear medicine starts with scheduling of an examination and ends with the final report of the results. There are QA aspects throughout the timeline of the nuke med exam. For example, scheduling. Was the correct exam booked? Did the patient get the appropriate information? And were there any contraindications for the test that we're performing, for example? When we actually then take a patient interview, the concept of the timeout has been discussed, checking pregnancy status, was the patient adequately prepped, and can the question on the referral actually be answered by the clinical test that has been requested? The radiopharmaceutical, correct radiopharmaceutical, correct dose by the right route. Did we pass QC? Did we check QC results? Did we do QC but then not actually check it before we did the injection? If you go on to imaging, did we We have protocols. We've discussed that. We have documented the protocol. Did we actually do the study following the protocol that we documented? Is the image of diagnostic quality? If not, did we repeat it? Has it been annotated? Did we reconstruct it? Did we display it the way reporting room would like to be displayed? Then we come to the report. Was the scan interpreted and reported clearly and correctly? Does the department have a mechanism to actually perform quality assurance in reporting itself? Did it answer the clinical question? So, and if there is a few physicians reporting, is there inter-observer variability? So these last slides, I hope, showed how we do, in fact, have to practice quality management on a day-to-day basis at every step. It is important to realise that the introduction of a quality management system, and especially if you document it, doesn't actually magically solve the problems of a department. I think that's something I found when I was going to some overseas practices, where everything is documented, there's a beautiful process map in place, and there's this imagination that therefore takes care of the running of the department and the quality assurance programs. It doesn't. It's simply a structure within which nuclear medicine can improve, but this improvement can only come about if we commit time and effort. So you could just read through those slides. What is important here is that it should be low maintenance. Whatever program we put in place should function in the background, shouldn't interfere with too much of what we are doing. It should not become tied down to bureaucracy, which it can at times, and it should not become a financial burden to us. So, coming back to I want to finish with where we started, which was the Deming's principles. Quality assurance and quality improvement is a science of process management. For quality improvement in healthcare, especially if you cannot measure it, you can't improve it. And here, Deming had this beautiful quote because he actually understood reality. In God we trust, but all others must bring data. And I think that's what's coming out of these programs. Quality improvement will focus on managed care. We can only manage the process. We can't manage our staff and get them to do and say, this is what we have to do. We can try and engage them, however, in how best to manage the process of care. It provides us a platform to ensure that our knowledge and skill base can be utilised safely within the rigorous frameworks of governance that many institutions now have to abide by. So I hope that gives you a snapshot of how quality assurance programs can be implemented. And I suppose we can go on to the audit at this point. Thank you for your attention. How are we doing for time, Liz? Oh, no, we can't. Soma has to talk. Sorry.
Gee whiz, I don't know. Why don't you just leave it to the chairs? We'll look after the session. It's okay. So let's invite our next speaker, who almost got away with not having to speak, to the stage. So Dr. Soma Samanasan, I apologise again. He's from Singapore General Hospital, and he's going to talk to us today on quality management in nuclear medicine and molecular imaging.
A very good afternoon to everybody, and I want to thank the organisers for inviting me for this session. Right, you're going to be hearing a lot of quality. We would definitely make you a high-quality participant by the time we finish today. What does quality management mean to a nuclear medicine department? The QA in nuclear medicine, introduction to the quantum checklist, and I will take note that what the earlier speakers have mentioned and try to go through it faster so that there won't be any duplication. Quality management essentially is an act of overseeing all activities and tasks needed to maintain a desired level of excellence. And we arrived at this definition from two different means. Kunti used the dictionary and I used the Google, and we still arrived at the same place. Includes the determination of quality policy, creating and implementing planning, quality planning, and assurance as well. In a nutshell, basically, total quality management looks after every aspect of our work. In essence, it looks at the request evaluation of the request for a particular procedure to be done, the preparation, the administration, the scintigraphy, and finally the reporting. And of course, not forgetting the archiving as well of the data if you want to look at it in a longitudinal timeline. What does QM mean for a nuclear medicine department? Well, it aspects everything else. I'm not going to attempt to go through this, but in essence, you could take it that it would involve every aspect from the time the patient is given an appointment to the time they come and register at the department, all the way through the scan, and finally the report is completed. So I'm not going to go through this further. It has been many years since the IEA has been developing it, as what Prof. Enrique has mentioned, from the mid-2000s all the way, and they've come up with a newer book. This one was available this morning at the convention exhibition site. I took a copy of it. I'm not sure whether there's any more left behind. As what Enrique has mentioned, there were about 39 centers with, dotted across the world who had undergone this quantum audit, and they had actually come from developing and developed countries as well as underdeveloped countries as well. And the audited centers had different socioeconomic settings, from huge departments with PET-CTs and molecular imaging and synthesis facilities, to all the way to units which had only one single scanner or even a rectilinear scanner. Now, the focus of quantum audits is essentially two, and one is patient care, that focus on the patient, due diligence, and for that, Colin as well as Kunti have spoken a lot in detail about that. And secondly, is a staff well-being. Staff have to be supported, and are they looked after? Is their occupational health safety looked after as well? And are they getting low enough occupational dose as well? Okay, so quantum audit methodology, as what Prof. Enrique has alluded to, uses a IEA checklist, which about 263 questions in them, from covering 17 checklists. And besides personnel and patient, they also look at the facility and the equipment, the kind of equipment they use, the kind of quality control that they perform on those equipment as well. So the audit is based on the entrance briefing with the stakeholders. It could be the CEO or CMB or something like that, who would also visit this audit during that process. And it takes about 5 days to undergo this audit, especially if it's a huge center. And then there will be an assessment of the nuclear medicine practice based on minimum requirements, international requirements. And of course, they'll come out with conformance and non-conformance, as what was mentioned in the earlier talk. And it ends with an exit briefing that is held with the stakeholders. Here's when the CEO or CNB can come back inside, and they would go through the findings, presentations of the detailed audit report, and of course, a written report with about 20 pages would be sent to the site as well, that looks into every aspect of the 5 days of audit. So follow-up action is taken by the center to mitigate these non-conformance. Now, it is not merely a paper exercise, because you need to go through the department. So that's why it takes 5 days. And as what Prof. Enrique has mentioned, it includes 4 people of 4 different specialities within the Department of Nuclear Medicine. That means a physicist, a pharmacist, a technologist, or a radiographer, and a physician as well. So the tour of the department is used to assess the workflow and work practices. So even though they could hide it and say that, yes, they have all the SOPs, but when you tour, as what Kunti just mentioned, is when everything comes about, you know? And you may be surprised with some of the things that you find as well. And are there hot patient waiting areas, and are they being mixed together with the cold patient waiting areas? This is something unique to nuclear medicine, where you call hot and cold patients, purely because of their radioactivity in them. And whether you have the corridors are wide enough to accommodate wheelchairs, trolleys, are there fire safety, etc. And of course, when you also enter the hot lab, and are there adequate measures in place to handle radioactivity? Do they use the correct shielding materials? If, for example, shielding is not shielding, in its entity, because technetium shields are not useful at all when you are dealing with iodine 131 or, for that matter, 511. So this is what you want to observe as well, whether they have the correct shielding and they use it appropriately. And the monitors, whether they have sufficient monitors for monitoring of the staff, as well as potential spills, whether they have sufficient of these audits. In fact, I was audited in 2014. My center was audited in 2014. It was a bit of an ordeal, allowing people to come into your department from across the world. And well, I was prepared. I thought I was prepared, but I wasn't, because the auditors found many things which we didn't realize ourselves, because a new pair of eyes, for example. And some of the evaluations, some of the suggestions given or recommendations given by the auditors were very useful, because when I told my administrators I need this and that for tens of years, never worked. But when the auditors asked for it, it did. I was surprised. I wonder why. Anyway, these are the 17 checklists. I'm not going to go through them. Enrique has mentioned them. And as you know, red is not so good. Green is very good. So 0 and 1 and 2, apparently you're going to get a red color box like this, as what Enrique mentioned. And of course, this is lots of red in here. So this center is not going to be doing very well. So the minimum requirements basically are something that the IEA has come out with, because you don't expect a single center, small center, with a single gamma camera with one doctor and one radiographer to be performing exceptional work. So they based on minimum standards. For example, let's look at this question here. It says, I'm sure you can't read it. Neither can I. Is the preparation of technetium radiopharmaceuticals from kits and generators carried out in a laminar flow cabinet? Or basically, they're asking whether it's done in a shielded biosafety cabinet. Okay, this is a minimum requirement that the agency has been supporting. So if you double-click on this, as what Prof. Enrique has mentioned, you will get a book come out. All right, and then the chapter as well, and then you can compare and see what is the minimum requirements. So there are no surprises in here, because they all mentioned out what are the minimum requirements, and therefore the center has to see whether they comply or they don't. Right, and then the non-conformance are broken up into 3 portions: critical, major, and minor. I'm not going to go through them. Minor means it's maybe some paperwork, some SOP is not complete, something like that. And major would be something that impacts the capacity of the nuclear medicine department of service to adequately perform its activities. Normally, they'll be given a little bit more leeway and about 3 to 6 months to accomplish their overcome their non-conformance. Whereas critical would mean that would impact on staff or patient safety. So that would something you could actually recommend to discontinue the service as well, because if you think that it's compromising on the patient. So examples of such critical findings could be they set their CT in a PET CT to a very high level, for example, and they overexpose the patients, for example. There could be one. Or another example, maybe. There is a electrical trip waiting to happen. Maybe you see the live and neutral wires sticking out of the wall, for example. This is considered critical because it could be impairing someone's life. Now, the radar plot has already been mentioned by Enrique very clearly. I will skip that. Some of the scenes in an audit, you can see they've got a whole big of files at the back of them. That's the amount of documentation they have to show. And happy, they must be very happy because of the results. They're all smiling. Now, in conclusion, for nuclear medicine service, the adoption of the QMS, or quality management system, should be a strategic decision taken with the aim of improving the standards of care provided to our patients. From the experience gathered through the IEA Quantum program, the area of radiation protection of both the staff and patients require more attention. That's what the 3 papers that are going to be appearing in the seminars of nuclear medicine, as what Enrique mentioned. And more specific training on preparing SOPs is needed, and strict adherence to them should be encouraged. And written procedures should be extended to all standardized activities. So what does this paragraph actually mean? Basically, the person doing the job should be writing the SOP, because he or she should be familiar with the work and hence would be the best person to write the SOP. It doesn't need to be in the perfect language of English or Spanish or Thai or whatever. As long as they can understand what it is, that's the best way it should be written. An introduction to a culture of periodic self-audits and continuous improvement. So basically, you're trying to inculcate a center to do its own self-audits. You cannot be there all the time to check on them, but rather, at least you entice them to do or teach them how to do the audit of themselves. So QMS definitely improves the service offered and positively impacts the standards of care that's offered by the department. Okay, these are my references. I hope I kept to the time.
Good, thank you. So we're going to hand over now to 3 of the speakers to do the mock audit. I think Kunti's going to run that. Is that right?
Yeah. One thing that I forgot to mention is that in September, next September, during the General Conference in Vienna, we are going to launch an app where you are going to have all the checklists, so you can do the self-assessment in an easiest way because you don't have to be filling papers or with the computer. You can do it with your mobile, your tablet, with all the checklists, the references, and all the tools that we have for Quantum. You are going to have it in an app.
I'm just trying it now itself. I have all of you downloaded, you can't see it from here, the MCI app on your phone? Have you done it? Okay, if you have, just go to the icon called Program on the first page, is the middle row on the left, and you will see Saturday, Sunday, Monday. So you just click on Sunday and look for our concurrent session right now, which is 2 to 3:30 p.m. Do you see that? It's in the orange heading. Just click on it, and you will see a whole series of talks, different talks. And let's look for the Technologist 4 at 2 to 3:30, QA and accreditation. If you just click on that again, you will come to another page with a blue heading, and in the center, you will see something called, this is an interactive session live. It's go time, join the session and participate. Just click on that once, and you will be at a question. Do you see that? Anybody has a problem? Just raise your hand, I'll come over.
Okay, so I think the way we put this together was to have a few slides and then a few questions. Just when you're answering these questions, oh, sorry, mouse doesn't work. Okay, so the purpose of this exercise, we're going to use Quantum as an example, but it can be adopted to any audit process. And we're just going to show a sample of questions. We just have to we are mindful whenever an audit is being conducted, and when you're answering these questions, we are looking at facts, so discovery and verification. The goal is to evaluate the evidence of the facts and the conformity from the evidence. Time must be kept under control, and we have to manage the audited person to keep things on track. I think the important thing here when we are going to go through this is to realize that only facts count. Impressions or our opinion of what it should be, just because we do it this way at the Austin doesn't mean Royal Melbourne has to do it that way. So it is facts that have to matter, not an opinion. We can't analyze everything when we go on these audits. We can only sample. So we try and sample wisely across the range of activities that is being performed. So we've covered this in the talk. So I'm actually not going to skip. And this is going to be Colin's.
So
the interactive slide, please.
So what we'll start is with the flash slide. So the question comes up. So what we'll do, if you'd like to select which option of how is training performed within your area, within your department, and as we do that, we'll have the answers popped up on the screen as we go through. That's my understanding.
So purple wins.
The purple wins.
Has everyone had time to do it?
Yeah, there you go.
Yes?
All right, we'll go to the next question if we can. So how do you keep training records within your department? A, B, C or D? I was going to say I didn't believe you. It's a combination of a lot of those. But centralised is certainly better from the department's point of view. Okay, next slide. Okay, another couple of questions that we'll go through as part of that process. Do your staff regularly attend CPD activities? And what are they? Very good.
It's still coming through.
Yep. Excellent. Next slide. And how do you again record your CPD?
Both.
Okay, next one.
Very good.
Next slide. Next slide. I've done those two. That's your complete.
Oh. Soma?
Right. Let's look at the slide. This one. Do you have separate?
You'd have to put up the question, please. Mm.
Should we look at the next slide? Do you know the question? I think he doesn't have the options here.
Oh, it doesn't?
Mm.
Oh, I think it's the next part, or?
No, it should be on this.
Ah.
Well,
Yeah.
Okay.
yeah. Anyway,
Okay.
you got the idea. I can see. The next slide. Can you see the last one? Are there any options? Then
There we go.
yeah,
Beautiful.
see. Yeah, okay. That's a no-brainer. Next slide. Next slide. Continue.
Oh, sorry.
So these are some of the protective equipment that the department can have. They just need to have separate, appropriate ones, as I had mentioned before. Next slide.
The next is Colin to go to the radiology.
I just want to get some radiology in there, so we put some extra pictures on. Sorry about that. So that's what we use in radiology. One of the new things that we're using in interventional is lead hats, protect your brain. Next slide. Some of the radiation protection, further to the previous slide, additional exposure rates, obviously exposure charts are used certainly in radiology for patient size, distance and positioning of the patient. Radiation regulations and safety compliance. So are there, within the departments, obviously, as we've been speaking about previously in the talks, are adequate facilities, administration of the radionuclides for doing the tools necessary for that? And is there a procedure for regulated monitoring workplace contamination? And is there procedures dealing for spillage or contamination incidents? Certainly in radiology, one of the things they look at is obviously overscanning of area of interest, and that's a classic for CT. Again, we don't hope to do it, but it does occur, wrong patient. And the other one is poor technique and having to duplicate the particular procedure that you're doing. So the question I think we've asked is, what errors do you document?
It's coming up.
This next slide.
Mm. two was? I forget.
Yeah, the first one was over scanning. Yeah, wrong patient,
Yeah.
poor technique, which is usual. A is usually the least. Okay, next slide.
So this one is next slide. So what do you properly identify your patients? There's no wrong or right answer. It's just the way you do it in your department. Some centers, like in Australia, you'd use three-factor identification. Okay, next slide. So this is if you have more than one language in your country, not the case in Australia, you may have to display your warning signs in different languages as well. And often a picture of a silhouette of a pregnant lady would be useful as well for those who can't read or write. So this is the next question. What is not required to determine the radiation dose of a nuclear medicine diagnostic procedure? Sorry about the long answers. Next slide.
Give you a few more seconds for this one.
Yeah, there's a lot. Mm-hmm. Mm-hmm. Very clear response.
Good.
Next slide.
Yeah, next slide.
Continue.
Next one.
We need another one, please.
So what is not a specific faculty planning requirement you would consider for a new equipment installation? Not the specific. That's absolutely right. Next slide. Who would be part of the evaluation committee of an imaging equipment purchase? That's very good. No-brainer as well. But you'd be surprised. Some centers don't have everybody there. It's just administrators make the decision. So sometimes even the user is not allowed to attend such meetings. Next slide.
This is okay. So this we've covered this. So we'll go straight to the question, please. And how do you manage your documentation? Is the question here. I was looking to see if cheat sheets would feature. Okay. Thank you. Next one, please. This is another question, please. What are the regular calibration and inspection of the equipment that you would do that conform to basic safety standards, whether it's local guidelines or international guidelines? We didn't have an all of the above.
Yeah. This is based, yeah, okay.
Yeah, we should have had an all of the above. Mm. Imaging equipment features. Mm-hmm. Next slide, please.
Next.
Unless Kunthi misspelt her name again. Yeah. So, with regards to the information systems within the department, the question is, how do your department specify the procurement and testing of new information systems or communication archiving? I think that's the question.
Yeah.
Yep. Yeah. Next slide.
So this is a clinically driven question. When in your department, is your injected dose optimized? And for the CT part of it, do you optimize the DLP in any manner? Do you have standardized acquisition reconstruction protocols? And are the scans checked off by a consultant?
Should have run a yes or no question on that.
Mm-hmm.
Show of hands.
Sure. Okay, thank you. Last couple coming up. The first one, please. It's pretty self-explanatory. If that could come up. Oh, did we miss one?
Skipped one.
Skipped one. Anyway, we could answer this question first. How do you perform a CT in those departments that have spec CT or PET CT? Oh, if you have a CT, if you have spec CT or spec CT, do you perform diagnostic CT, or would you perform a fixed dose, low dose CT, or would you modulate your CT dose? Mm-hmm. Low dose CT modulation. Okay. Next one, please. And this is going back to the first question. If you, for injection of an MDP dose, for example, or for your whole body FDG dose, how would you calculate the dose? Is it a standardized dose for all bone scans or all PET scans? Would you tailor it to BMI? Would you tailor it to body weight? Or do you have another way of tailoring to patient requirements? Tailoring to weight wins. Mm-hmm. Next one, please. Last one. If you, in your department, if you're running clinical trials or if you're involved in theranostics, is it conducted in a clinical situation? Is it a clinical service that you provide? Or do you conduct it as part of a trial? Would you use standardized protocols? Is it a multidisciplinary approach? In fact, the question is not set up to be answered that way. So can we have a show of hands, plan B? How many would do it as a clinical scenario? Mm-hmm. And trial-based scenarios? Mm-hmm. Same culprits. Do we standardize protocols in these instances? Mm-hmm. Yes, I think a multidisciplinary approach. And are dose limits and toxicities observed and documented? Protocol violation submitted? Adverse events noted? Yep. Okay, so that was just a brief snapshot. Thank you. If you had any questions to ask any of us, we could answer. We can try.
We thought